Hello and welcome to this video on modeling and problem solving with linear equations, part 2. Alright, so maybe you want to pause the video and attempt these two questions, and if you're having trouble then keep watching. Let's check it out. So this is the general process, and I went through this in further detail in part 1, so maybe go back and watch that, and we're just going to work through it. Let's go. Okay, so first question. A tank holds 65 litres of fuel. It contains 8 litres of fuel initially, and the petrol pump fills it at 4 litres every 10 seconds. Write a linear equation for the amount of fuel in the tank after t minutes. Okay, so first, you want to have a little think about what the graph would look like here. All right? Is it going to be increasing? Is the fuel in the tank going to be increasing, or is it going to be decreasing with time? Pictures, you're filling up fuel at your car. Are you hoping to increase the levels or decrease? That's right, you're going to be increasing. So we would expect a positive gradient. In other words, a positive m value. I'm just going to make a note there. It's pretty important. So it says write a linear equation for the amount of the fuel in the tank after t minutes. Now, another thing, let's underline some keywords first. So a tank holds 65 litres of fuel. It contains 8 litres of fuel initially. Now, I know that the word initially means the y-intercept. Initial means the y-intercept, so that's a hint there. And the petrol pump fills it at 4 litres every 10 seconds. Now that is a key to look at the gradient, because that is a rate. That's a rate, right? So before I do anything, I guess, I'm going to write, if it's a linear equation, let's just write the general form of it. Y equals mx plus c. All right, now let's go ahead and have a look at what our m and c value might be. So I said initial value. The initial value is at when time is 0. C is 8 litres. Now, what have we got? The m value. Now they want our linear equation after t minutes. So you need to, so we're given 4 litres every 10 seconds. Now, it's important. These can be quite confusing. 4 litres per 10 seconds is the same as 4 litres. You can rewrite that as a division sign there, like as a fraction. So 4 litres every 10 seconds, but we want our equation in minutes. So I'm going to convert 10 seconds to minutes. How can I do that? So I know that the factor is going to be 60. What do you think? Am I going to be dividing or multiplying by 60? All right. You're going to be dividing. Okay. There's a lot of seconds in a minute. You're getting to a bigger unit. You've got to divide by 60. Hopefully you know how to convert seconds to minutes. So 10 divided 60. And it's it could be a fraction actually. It's 1/6. Okay, so that is going to be our m value. Oh, actually, no, it's not. Sorry, bad start to the video. So 10 seconds is 1/6 minutes, right? So I'm going to just replace that in my rate equation. 4 litres over 1/6. 4 divided by a 6. You can do that in your calculator, or you can say that that's timesing by the reciprocal, but let's not. 4 divided by a 6 is 24. So that's a key. You need to get it in the right units. When I initially did this problem, I just immediately divided 4 by 10, but yeah, be careful. So our gradient after all that work is 24 litres per minute. Now I'm going to put that in a box because I need it. I've got my C value and I can come back, actually, yeah. So I can come back to my equation over here and substitute everything in. So M was 24, C was 8, and let's replace our Y and X values. So deciding, what have we got? Remember, time is always on the X-axis. That's a dead giveaway. Time is X. And then the other variable, A, the amount of fuel in the tank, must be Y. So that is our equation. A equals 24t plus 8. Now let's make this a bit smaller so I can fit things in. Whoopsie doopsies. Okay, now I know that was a bit weird. Hopefully it makes a little bit of sense. Just get your units right and everything will be all right. How long will it take to fill the tank? How long? So I've got my equation. A equals 24t plus 8. This is where our data table comes in handy. So how long? You're thinking, okay, well, what am I finding? Am I finding the time or am I finding the amount of fuel? If it's asking how long. I'm finding time, so I don't know time. Now, what on earth? It feels like they haven't given us enough information. But if you go back up and read the question, it says a tank holds 65 liters of fuel. So when the tank is full, it holds 65 liters of fuel. Okay, that's when full. All right. So that means we're given the amount of fuel in the tank. In my little data table, how long does it take to get to 65 liters? And there's our data table. We're ready to substitute in. So I'm just going to write the equation again so I can substitute directly underneath and not get confused. A is 65, so I substitute that. 24. T, we don't know, so we've got to rearrange, sadly. Now, I circle my variable, and let's do it. So I want to get T on its own. 8's over here, got to get the normal numbers over the other side. Take it away. Opposite of plus 8 is take 8. And let's simplify. 65 take 8 is 57. 24T 8 take 8, well, that's just 0. Don't need to write anything. Getting closer to an answer. 24t, well, that's the same. Let's divide by that 24. And then the 24s will cancel and we will have an answer. 57 on 24 is 2.375. And what are the units? Come back to the question. Our equation was in terms of minutes. So if you wanted to convert that to minutes and seconds, you can go 2 minutes plus, you can separate that out, 0.375 minutes. Now, if I want to convert that to seconds, I times it by 60. So I've got 2 minutes plus 0.375 plus 60. Times 60. Times 60. 22 seconds, about that. So that's how long it takes to fill up the tank. Just a couple of minutes you'll be at the petrol bowser filling up your fuel tank. And now it says, how long will it take to add 40 liters into the tank? So maybe we're going to do that one up here. Part 3, we've got our equation. Our equation is A equals 24t plus 8. And I'll do a little data table over here. How long means we're finding what the time is to add 40 liters to the tank. So this time we're given A as well. And we're just substituting again. So just solving this. A is 40, 24 times, T's are unknown. And let's solve it. I'm going to take away the 8 from both sides and slowly isolate that T. 40 take 8, 32, 24T, the 8's cancel, 24, dividing on both sides by 24. That will cancel. 32 and 24 is 1.33 minutes. And I'm not going to convert it here. Just use that same method over there. Separate out the decimal and then times by 60. But let's get on to the next question before I confuse you to death. Let's check out this. Let's get a bit of a different color going on. Oh, color going on. Okay. Everything is all right. Okay. A tank is initially full with 3,000 liters of water. Let's underline some keywords. Initially full with 3,000 liters of water. Water is being used at a rate of 25 liters per minute. Write a rule for the volume V liters of water after T minutes. Now have a think about this one. It's always handy to think about, is it going to be increasing or is it going to be decreasing? Now it says it's initially full and water is flowing out of it, right? So its volume is decreasing. So that is important. You're going to have a negative M value here. That's what you should expect. So you just got to be careful. They try to trick you sometimes. So make a little note to yourself what this problem would look like. It's going to be decreasing with time. So write a rule for the volume of water after T minutes. So it's a linear equation because the unit is on linear equations, so we'd hope so. Write that general formula. And now we've got to work out, okay, our key variables from the thing. Now, initially full with 3,000. Wherever you see initially, that is a key to your y-intercept. Initially full. So I'm going to write that over here. C equals 3,000. Okay, and I can put that straight in here. Water is being used at a rate of 25 liters per minute. Now remember, I said it would be a negative M value, so be careful. Negative 25 liters per minute. It's flowing out of the tank. So I'm going to have to say, negative 25 because, and remember the gradient is a rate. That's why I know that that's the M value. Coming back here, gradient is a rate. All right. Whoops. Okay, and then let's get our real world variables in here. Now I know that time is always X. Time is always on the X axis, so that's a nice giveaway. And volume must be our Y. It's the only thing left. So there, we have done our rule for linear equations. And I'll put a box around that because we'll probably be using the rule soon, okay? Okay, what's next? And yeah, just checking those units, it was per minute and we were asked for minutes, luckily, because I'm not in the mood to convert to seconds again, I tell you. Now, determine the volume after 2.5 hours. Oh no. Well, they're just making me convert because they're doing hours. Okay, it's fine. I can do this. So, data table is your best friend. Determine the volume. That means the volume's unknown. After 2.5 hours. Well, hours is time. But I know that my equation is in terms of minutes. So I've got to first convert those hours to minutes, sadly. How do I convert hours to minutes? Well, I know that the conversion factor is 60, and it's just whether I divide or times. And I know that there is a lot of minutes in an hour, so I'd expect the number to be getting a lot bigger, right? So I'm going to multiply. So 2.5 times 60, 150 minutes. I think I've wrecked the numbers a little bit. So maybe we are going to actually make that, sorry to be a pain, we're going to determine the volume after 1 hour because I have made a mistake with the question, which is great, but that's fine. This is me adjusting questions from the textbook and I didn't check them properly. So let's just say after an hour is 60 minutes. Negative 25 times 60 plus 3,000. Okay, negative 25 times 60 plus 3,000 gets us a positive answer, which is nice. Just gotta... But don't change the question on the exam sheet. I don't think your teacher would like that. So volume is 1,500, and think about the units of your answer. The volume is going to be measured in liters. Okay, so after 1 hour, that's the volume. Okay, part C. How long will it take for the tank to become empty? Now, data tables are our best friend. So, how long means we're finding what time is. Will it take for the tank to become empty? Now, think about what volume that is. When is the tank empty? At what volume? There's going to be nothing left, right? It's empty. It's zero. There's nothing left. So that is our little data table. And let's use it. V equals negative 25t plus 3,000. Okay. Negative 25. Oh, so I'm substituting V as 0. T I don't know, so we've got to rearrange. And circle T. I'll get rid of this 3,000 first. It's furthest away. And 0 take 3,000 on the left-hand side is going to be negative 3,000. The 3,000 take 3,000 cancels. We've got negative 25t. And I might just move this up a little bit. That didn't quite work, did it? Whoop. So, we've got that. Let's get rid of that negative 25 by dividing by negative 25 on both sides. And negative divided by negative is a positive. And 120. So the time is 120, and think about what our units are. Will it be minutes or hours? It's going to be minutes since we plugged in minutes down here. Our equation is in terms of minutes. So I'm going to put that there. That's how long it will take for the tank to become empty. And that would explain why in part C, 2.5 was a weird negative answer. Because it's already empty. Can't get more empty than that, right? After 2 hours, you know? Let's check this out. Last question. Yay. I'm ready to call it a night. How long will it take for the tank to have 600 liters left? Again, how long means we're finding time to have 600. So we're given the volume. That's nice. 600 left. Let's use our equation again. What am I doing? Yep. Volume, negative 25t plus 3,000. Our volume is 600. So substitute it in. And take 3,000 from both sides. Take 3,000. Simplify. 600 take 3,000, should be a negative 2,400. And that cancels negative 25t. And dividing by negative 25 on both sides. 2,400 divided by 25, since it's... So we've got t is 96, and your units, again, are minutes. So it takes 96 minutes for it to have 600 litres left. Now, yeah, these are your key tips for linear modeling, so just lock this in your mind, all right? Yeah, I'll let you read through that, but hopefully that helped. I apologized if it confused further. I've done a few videos tonight. Maybe I've just gone too far, but I'll see you in the next video.